new ways of delivering multimodal drugs. And I will start simply saying that due to our very complex network, we should disclaim the view and conclusion of this research. Actually, is just a piece of a very complex research, and we have a lot of partners as you will see at the end. Just to mention the FDA, Air Force Scientific Research Center, the National Institute of Health, and so on. And it's important to acknowledge the contribution of Uppsala University and the Cluj University in Romania in this long project. I would say we started more than 6 years ago to develop these particular aspects and some animal models, very interesting animal models with comorbidities. Now, I will simply acknowledge the fact that many advances have been done in the last decade, and whenever we are trying to talk about treatment-related concepts, strategies, and molecules, we should correlate this with neurobiology. Otherwise, it will happen as actually it is the case of neuroprotection, which is an incomplete concept, and I would say even a kind of inconsistent concept. So in order to have in mind the developments, I will acknowledge just these 4 important take-home messages: that today we should address everything to neurovascular unit, not only to neuron, because all the functions are provided by neurovascular unit as a whole. Then the synergistic molecular effect, as there is no one molecule able to deliver a single effect for brain function. Post-lesional brain regulation particularly, and the concept of neuromodulation, it's extremely important and will make the difference in the future. And in relation with these 2 important topics, post-lesional brain regulation and the concept of neuromodulation, I would like to acknowledge that after acute brain lesion, there is always an endogenous post-lesional regulation, and this endogenous post-lesional regulation consists of 2 sequences. The first is neuroprotection, and the rest is related to trophicity, plasticity, and neurogenesis, which actually is boosting the neuroregeneration. So 2 sequences, neuroprotection and neuroregeneration. There is a very clear time sequence that is acknowledged today for this holistic, I would say, rather process than sequential. And today we define this as endogenous defense activity. So these 2 sequences are very, very important. And this is basically the sense and the reality of post-lesional brain regulation. On the other hand, we have damage mechanism, and damage mechanism, this mechanism is also a new important challenge for us, because the new vision is that behind all these pathophysiological mechanisms are usual biological processes which are in balance during the damage process. Actually, for example, excitotoxicity is an imbalance in MDA receptor stimulation, and excitotoxicity is the bad part, but the good stimulation of excitotoxicity will contribute to plasticity. So actually, the all pathophysiological mechanism represents imbalances in normal processes. So therefore, we should not suppress or overstimulate these processes, but we should modulate. And the modulation is the current philosophy. And this is in line with the new findings. We used to classify endogenous molecules by their effects somehow in a dichotomic way. But today we know that there is almost no one molecule being bad or good. For example, we know that TNF-alpha, which was classified as a bad one, is an important player in a certain sequence for neuroregeneration when acting on receptor 2. Also, for example, trophic factor, BDNF is useful, but the pro-BDNF is inducing apoptosis. So all these balances are also in favor of modulation. What we are doing in our vast research project is to focus on the blood-CNS barriers, and particularly on blood-brain barrier. And we know that blood-brain barrier is just a tiny little part of neurovascular unit, and we try to create animal model by calibrating very specific and reproducible etiological agents like heat stroke, so basically a very well-defined time and as a level of high temperature, usually 38 degrees for hours. So this hyperthermia is the key of having a very nice stable model, and then to evaluate the capacity to protect against different etiological agents our brain. And in this respect, I will just point towards this important biomarker with this nitric oxide synthetase, and the role and the effect of NOS in this blood-brain barrier damage. We know that it's a strong correlation between the overexpression and the blood-brain barrier breakdown, edema formation, and neural damage. And we published a lot of papers clarifying many aspects regarding NO and brain. And also our work is focused almost on how to protect and how to use different molecules. So we use different molecules and in different dosage to protect against particularly this blood-brain barrier breakdown. And we had a very interesting result. And what we realize is that for a certain etiological agent, it is very, very important, the context and the comorbidity of the subject. So we created an animal model with double and triple comorbidities, and we demonstrated, and currently we are investigating the best dose for neuroprotective drugs for animal with triple comorbidity, and we demonstrated that there's a clear correlation between the number of comorbidities and the level of neuroprotection that we have to address, actually the dose. And our observation is that aggregated comorbidities heavily influence the need for neuroprotection in respect to dose particularly, and comorbidity is an independent influencing factor to be considered for translational issues, and also to be considered for the new design of neuroprotection and recovery, clinical trials. Protection and recovery is very important to be linked together. And this is different than dosage being an independent factor as well. So I will not elaborate too much on how we create these animal models, diabetic and hypertensive animal, and as I have said, the heat stroke was and hyperthermia was the etiological agent that we created. We used to have the 2-kin-A1 model and diabetic induced by streptozotocin. And I will jump directly to the results, and I would like to mention that actually the more comorbidities we have, the higher is the need for more consistent dose for anti-stressful agents and protective molecules. So we define the correlation between blood-brain barrier permeability and brain edema as a linear function. The heat stress is creating a lot of damage, and particularly blood-brain barrier disruption. The level of sensitivity is different in different areas of the brain, as you may see here in different areas. You have different levels of brain edema after the same intensity of an etiological agent. Also the blood-brain barrier leakage is different in different areas. Also the level of tissue injury, direct tissue injury is different. And also the overexpression of heat stress proteins. So what we observe also, that it's not only a correlation between an etiological agent comorbidity and the need for neuroprotection, but also the type of drug is very important. And multimodal drugs are more efficient than single monomodal drugs, single mechanism monomodal drugs. And we explore more than 20 types of molecules, and actually it's common knowledge with the multimodalities is the capacity to create at the same time protection and regeneration without disturbing each other. And we use Cerebrolysin for this, as this is one of the most prominent multimodal drugs, and it's also very well known that this is the only drug available for clinical use containing active fragments of trophic factors. We had a lot of good results in our research on different animal models. I just listed a couple of papers here published, and what we decided is to go ahead with the technologies and to try to use the nanoparticles and nanowires, and we wired Cerebrolysin, and this is a proof of our success, and this was awarded in May in National Innovation Summit and Showcase in Washington, and we have, let's say, the pleasure to acknowledge this, and what we used was this type of titanium nanowires with this aspect to wire Cerebrolysin, and what we found is that nanowire Cerebrolysin, it's almost double in the sense of efficacy comparing with the normal one. So we can, I don't have more time to show you the superiority of this, but this is clear that there is a clear superiority, and just to draw the conclusion, our observation demonstrates that the comorbidity factor exacerbates brain damage in heat stroke, and NOS is one of the important agents, and we can measure this in a very reliable way, and furthermore, neuroprotection depends on the dose, but not only depends also in the way in which we are delivering drugs, and nanotechnologies are highly contributing to this, let's say, strongly positive effect and the better development and outcome after the treatment. Thank you very much. I would like to acknowledge our large group and the general support of different agencies working with us, our group of collaboration, and to invite you for our 9th Congress of the Society for the Study of Neuroprotection and Neuroplasticity in Prague next October. So in 1 month or so. Thank you. Questions? If not, we can talk during the break, as I would really like to keep the time.